Okay. All right. Thank you for coming. Welcome to NAMM and welcome to the MIDI Association booth. My name is Mike Kent. I'm on the executive board of the MIDI Association, and I'm the chair of the DAW Control Profile subcommittee. And we've been working for about 18 months on this project, and we'd like to show you our progress so far and talk a little bit about what we're doing later this year. Okay. So I'd like to talk to you about control profiles. And this is primarily for DAW, but it's not just DAW. But we certainly have a focus there. And using MIDI 2.0, we know that there's always a dialogue between devices in MIDI 2.0. And so the idea is to take advantage of this ability for an external controller to talk to a DAW and send commands to the DAW, and the DAW can reply back. And so all different kinds of controllers. In general, many of these are hardware controllers, maybe a keyboard with controls built in, or a dedicated controller, or it could even be an external piece of software that's talking to a DAW to control it. And then the DAW can report back to the controller on any commands that it receives. So the first thing that we've been working on is a transport location control profile. And that one is nearing completion. And we're just starting to work on a dynamics controls profile. So we'll talk a little bit about those and also other things that we'll be doing in the future. The transport and location control profile is really quite simple. It is about a controller controlling the playback head of a DAW or other device. Play and start and stop and record on off, fast forward, rewind. These basic transport functions are defined by a MIDI 2.0 profile. So by that means we define which MIDI messages should we use for these functions. But not just those transport functions, but related, we have markers, punch in and out marks, loop in and out, jog shuttle commands, and a bit more, all around this idea of transport and location control. And so the basic design is that an external controller sends commands to the DAW, and then the DAW acknowledges that it receives the commands and reports back its status. You told me to play, I am playing, would be an example of that. In addition to that, the DAW also reports the current playhead location back to the external controller, so that if it has a display, it can display to the user the current time. We have a demonstration. We're just going to switch over to computers here. And these guys have thrown together a demonstration that they finished building just 2 hours ago. So let's cross our fingers and hope this works.
Yeah. Hi, my name is Jochen Trappe. I'm a software developer at Steinberg working on Cubase MIDI controller integration. And yeah, we teamed up with the colleagues at Native Instruments who provided a special prototype firmware for the Complete Control Mark III, and I implemented the, thank you, okay. Yeah, I implemented the Cubase side of that. So yeah, and yes, we just finished 2 hours ago. So let's see. I have the USB cable of the Complete Control in my hand. So what you see down there is the not activated transport control profile implementation, and I now plugged it in, and yeah, you see it's automatically detected. It's not detecting the device, it's detecting the transport control profile as a contract, so to say. So now, and Andrew, might you, yes, and not record, please. Yeah. Just, okay. And yeah, I think we implemented the scrubbing as well, yeah. Okay, but no worries, no worries. is good enough. So it's not a product, it's a prototype, of course. So what the actual benefits are, Dice will talk about it a bit more, I guess, but already I can show an immediate benefit if we now plug in a second device. So there's this protozoa device for prototyping MIDI 2, and so I plug the complete control out, so the profile is now deactivated again. And I plug in another device that is totally unknown to Cubase. Cubase only understands the control profile concept. And again, it's activated, it's working. It's okay. It says it's working. Let's figure it. Okay, a bit shaky, but you get the concept, I guess. Yeah, we're presenting an idea here, of course. So, yeah, the idea is you plug in a device that implements, one or more of those profiles, and yeah, you're ready to go. Okay.
Thank you. Andrew?
I think you've covered everything.
Okay, worked. Thank you. That's quite brave to build a prototype, in a couple of hours and then demonstrate it right away. So thank you. So this transport and location control profile will be published soon. We expect in Q2. And this is a MIDI 2.0 specification, and taking advantage then of industry standard ways of doing this that are common across all DAWs, and any device can implement this profile. So that we don't need special scripts. We can just plug in, and using the discovery mechanisms provided in MIDI 2.0, the device just appears. When you unplug it, it disappears. And so this bidirectional discovery is a key feature in MIDI 2.0. And here we see that working immediately with this prototype. Okay, so the next thing that we've started now that we're finishing up the transport location profile, is a dynamic controls profile. The idea of this profile is that we used a fixed set of messages, MIDI messages, and so the external controller doesn't readapt or change, it just keeps sending out the same information. If it's got 8 knobs, like this device here, if it's got 8 knobs, it just sends 8 messages and they never change. It's the DAW that decides what those 8 knobs are going to do. And so this dynamic assignment can follow focus, or the DAW can assign those knobs to any destination. It's the choice of the DAW, and the external controller doesn't need intelligence in order to reach different parts of the DAW. The DAW can do that. Okay, and so the pots on this device, or faders, send direct controller values, and coders can send relative values. So we have either direct or relative controls by way of MIDI 2.0. And the DAW can report back to the device. So if it's like this device and it has a display, the DAW can report back when you're controlling a knob. It can tell you what property it's currently assigning to that knob, and tell you in user-friendly values, you changed the waveform from sawtooth to pulse wave. So we can send back friendly names back, or friendly values back to the device. So this is the next project we're starting. If that interests you, join the MIDI Association and help us develop that specification. When we're finished with that, probably later this year, we're going to start on other profiles, including navigation, or there's some debate, maybe navigation should be part of that dynamic control profile. If you think that's the case, please join us and tell us what you think. We'd love to get your feedback. And later, we'll probably move on to a mixing control profile. These things are not just for a DAW. They can be used with other devices that have a timeline, for example, on that transport and location. So if it's a sequencer built into a keyboard or a drum machine or something like that, these same concepts can work with products, not just a DAW. But our idea behind all of this is that any product could implement this profile, and I could plug that into a DAW. If I've got a hardware controller, if I implement these profiles, I don't have to know anything about the DAW, and the DAW doesn't have to know about my hardware. They just both say, hey, could you do the MIDI 2.0 profile for DAW control? And if the other device says yes, they both turn on and it just works. So this saves writing scripts, it saves user configuration. So I'm gonna ask Dice to tell us just a little bit more about that and why that's valuable.
Yeah. Hi, my name is Dice from FSK Audio. In my past life, I was a avid Pro Tools product designer. And like something that you just see here, like I'm sure you guys, you have hardware, you have a DAW or some kind of software or another device, and the transports control each other. Like you've seen that before, but for that to actually work, like you need work, the developers need work on both ends, right? DAWs provide really wonderful scripting support so that hardware manufacturers, if they choose to support that particular DAW, they can work on that script, and specifically they would be able to control a particular DAW. But I also consult for a particular DAW company, and one of the main issues that I've been seeing or hearing recently is that yes, this DAW does have scripting and it does support third-party hardware, but a lot of new hardware doesn't support it, and it's because the manufacturers have to go and put in the work. The hardware manufacturer have to go and put in the work to support that particular DAW. Trying to support all these multiple DAWs is a lot of work. Back in Avid, I was a product designer and owner for, the Complete Control. So Complete Control Pro Tools support, I worked on that, and I just wanted to say it was a lot of work. Like everything was laid out for us, but it was a lot of work. And then imagine having to do that for multiple companies, multiple products. So the whole idea behind this is that for the developer, it's a lot less work, because you implement the profile once, and then any product, DAW software, hardware that supports that profile will simply work. So that's wonderful, right? I think the closest thing we have to that right now is Mackie and MCU, and that's like 25 years, 30 years almost old, and there's a lot of limitations to it, which our DAW support profiles will be a lot more integrated than that. And the other side is that for users, it's a lot easier, because now there's a lot of configuration that goes on for when you buy a new product, like if you buy a new controller and you want it to work with your DAW, it's a lot of configuration you have to do before it works. So we're trying to ease that in with this profile as well. And to have something like that, that's not a proprietary format, that's open to everybody, wants to use it, it's open standard, is where I think we're going and we should be going. And I hope we get a lot of support from that from all manufacturers, and especially users who might be frustrated because this brand new keyboard controller that they bought works with one DAW but doesn't work with the other one, and you're like frustrated because of that. So we're trying to build a world where that doesn't happen. And I think that's where the value is. And yeah, if you want to find out more, please contact us, and please join us, because it is an open standard, and we it's a collaborative work, and we welcome new members. Yeah.
Hey, so look this way. This is evidence from my wife that somebody wants to hear what I have to say. We're up here. Thank you for listening. If you're interested in this, email developer@midi.org. If you're a developer of software or hardware that might want to implement these things, that email goes directly to Andrew. Andrew is an expert on all these things. He is the chairman of the Technical Standards Board, and he's also the editor of these specifications. So he knows these things deeply, and he'll be here afterwards or back on the other side of the aisle here. If you have questions about any of these things, reach out. Andrew's probably your best bet, but Dice, Jochen and I are also available if you have questions. Are there any questions that you'd like to ask on microphone? There's a microphone down here. We'll answer questions here. I don't see any hands going up. Thank you for listening. Oh, Kenneth has a question.
Can you hear me? Oh, now.
There we go.
First of all, let me say thank you guys for showing up today. It's been incredibly informative. So is this proprietary? Is there no patent supplied to this? This is going to be open for all?
Sure. This is MIDI. This is all done by MIDI, and so it's all completely open. And that's the idea of this, is that we want everybody to do these things this way, so we don't have to build custom scripts or custom integrations anymore. We can do all of this with open industry standards that are patent-free and documented, freely downloadable at MIDI.org.